Hello, today we're going to talk about the Pythagorean Theorem, and on the next page we're going to go ahead and talk about the Pythagorean Theorem's converse. Pythagorean Theorem is something that we use with right triangles, and hopefully all of us have covered this, or was covered in their Algebra 1 class. If not, we're going to go ahead and discuss it today. The Pythagorean Theorem states if you have a squared plus b squared, it's going to equal c squared. The way that looks over here is if we have a leg a leg B, and a hypotenuse C. When we square each of the respective portions, we're going to go ahead and get this formula right here. A squared plus B squared equals C squared. Another way to think about it is leg squared plus leg squared equals hypotenuse squared. And we're going to use that throughout this whole 8.1 Pythagorean theorem, the first part of the video. So the first page, we're going to use this throughout. If we go down here to our examples, we've got what we will learn is one of our special right triangles. I've already kind of done some of the work for us, but we can go ahead and follow along as well. So in this case, if we were going to try to solve for the missing side here is C, or it's the hypotenuse. We have our leg. Remember, the hypotenuse is always across from the right angle. So if we go ahead and go down here and we take 3 squared plus 4 squared equals c squared. 3 squared is 9, 4 squared is 16 equals 16 squared. If we continue on over here, 9 plus 16 equals 25, and that equals c squared. We're going to go ahead and take the square root of both sides, and c is going to equal 5. That is our answer. Going on to this next problem. We have a leg, but it's missing. We're going to just go ahead and label that B. It doesn't necessarily have to be B. It could be X. It could be A. But to be consistent, I always like to think that the shortest side is what I refer to as A. So the shortest side, or the shortest leg, is A. The medium side, or once again, leg, is B, and the longest side, or hypotenuse, equals C. So those are some things. This is the way I usually like to think about it. It doesn't necessarily matter, but this is the way I like to think about it. So if we've got a leg missing and we have a hypotenuse and one of our legs, we're going to go ahead and set this up like so. We've got 6 squared plus, I like to think of it as b squared because it looks like it's the medium side, equal to 12 squared because that is the hypotenuse. So we've got a squared plus b squared equals c squared. A squared, 6 squared is 36 plus b squared equals 144 because that is 12 squared. We're going to go ahead and subtract 36 from both sides, and we're going to go ahead and get b squared equals 108. We're going to take the square root of both sides, and we have b equals the square root of 108. Now this gets into our simplifying radical stuff that we just got done working on in chapter 7. So let's go ahead and figure out what goes into 108. If we have no idea what goes into 108, we can automatically know that it's even, so we can divide by 2. 108 divided by 2 is 54. 54 divided by 2 is 27. 27 is no longer even, but we might be able to notice that it's 3 is a factor, so is 9. And if we continue, 9 is 3 times 3. Here we've got 2 times 2. So we're able to go ahead and pull out a 2 and a 3. So b is going to go ahead and equal 2 times 3. What's left is this 3, radical 3. We do some simple math here. B is going to be 6, radical 3. So if we go back to over here to our original problem, we're going to know that this leg length is going to be 6, radical 3. Now, let's go ahead and take a look at a couple more examples here. Once again, I've worked out most of these for us, but I'm going to work it out in a little bit nicer handwriting over here on this lined piece of paper for us. So So looking at this next example, we're going to determine the missing length. Write the answers in simple radical form. So over here on this next example, we're going to go ahead. This is our leg. This is our leg. This is our hypotenuse. And we got leg squared plus leg squared equals hypotenuse squared. In this case, they just labeled it x. Like I said, it doesn't matter. You can think of it as c because the hypotenuse is c. So we're going to go ahead, start a new problem. We've got 2 squared plus 6 squared equals x squared. 2 squared is 4, plus 6 squared is 36, equals x squared. 36 plus 4 is 40. Set that equal to x squared. Take the square root of both sides. I'm going to go ahead and flip it around just because visually I like the way that looks better. And x equals the square root of 40. Off the bat, we notice it ends in 0, so we can take out a 10, and hey, look at that. 4 is perfect. 2 and 2. I think hopefully we notice by now that once we get to 10, we know that 5 and 2 aren't going to help us out. And our hypotenuse length is going to be 2 radical 5. Looking at our next problem. Right here, we've got a hypotenuse, a leg, and a leg. So in this case, we're going to be looking for our leg. So once again, I like to think of the shorter side. This visually looks like the shorter side, so I'm going to go ahead and put 4 squared plus b squared equals c squared, which is 12 squared. 4 squared is 16 plus b squared equals 144, because that's 12 squared. Subtract 16 from both sides. B squared equals 144 minus 16. 144 minus 16 is going to go ahead and give us 128. We're going to take the square root of both sides. We'll get b equals the square root of 128. And we'll start thinking about the perfect numbers that go into 128. Let's go ahead and say 4 goes into 128. 4 goes into 128 42 times, or 32 times, excuse me. Here we know 8 times 4 is 32. We have a pair of 4s. 8 is 4 times 2. 4 is 2 times 2. So we've got a set of 4s and a set of 2s, so we can take out a 4 and a 2. And what's left is this 2. Radical 2. 8. 4 times 2 is 8, so our answer is going to be 8 radical 2. So the side that we're missing here, this leg, is 8 radical 2. Hopefully we're picking up the idea here. We've got a couple more problems we can do. Let's go ahead and do this next one. We've got our hypotenuse, we've got a leg, and we've got a leg. So let's do leg squared plus leg squared equals hypotenuse squared. So they're going to go ahead and say x squared because that's what they gave us. Plus 2 squared equals the square root of 53 squared. Now don't worry about this with square root of 53 squared. It's just going to be 53 because square roots and squares are inverse. So we set that equal x squared. 2 squared is 4. Square root of 53 squared is just 53. Subtract 4 from both sides. That gives us that x squared equals 53 minus 4 is 49. Take the square root of both sides. X equals 7. So that side we were missing right here is going to go ahead and be a 7. On this next problem, we're given a square. We know squares that all 4 sides are going to be congruent, so we're going to go ahead and know that that's going to be 9 as well. That'll be a leg. This will be our hypotenuse, leg, and a leg. So leg squared plus leg squared is 9 squared plus 9 squared equals hypotenuse squared. Let's go ahead and call it x squared. You can call it c squared. You can call it whatever you want, really. Excuse me. 9 squared is 81 plus 9 squared is 81 equals x squared. 81 plus 81 is 162. That equals x squared. We're going to go ahead and take the square root of both sides. If we go ahead and think about this, we're going to go ahead and divide by 2, and we're going to get 2 and 81. 81 is perfect, which is 9 times 9. We're going to go ahead and circle it. Whenever we circle something, that means we have a squared, which means we're able to take it out of the square root, which gives us the answer of 9 square root of 2 equals x. And in our case, this is our hypotenuse. Later, we're going to go ahead and learn some of these special right triangles that we have, and dealing with angles and things like that, but we're not going to go ahead and worry about those for right now. So we've got two more examples here, and then we'll move on to the next page. So our next example here, we've got a hypotenuse, we've got a leg, and we've got a leg. This one appears to be the shorter, so let's just go 8 first. So we're going to go 8 squared plus x squared equals 20 squared. 8 squared is 64 plus x squared, 20 squared is 400. We're going to go ahead and subtract 64 from both sides. X squared equals 336. And now we're going to go take the square root of both sides. Take the square root of both sides, and x equals the square root of 336. And since it asks for the simplest radical form, we're going to go ahead and simplify. What goes into 336? We don't exactly know, but let's go ahead and try 3. That leaves us with 112. 3 times 112 is 336. 112 is even, so let's go ahead and divide by 2. That leaves us with 56. 56 divided by 2 is 28. There's a 4 that can go into 28. 4 is perfect. 2 and 2. Here's another 2 and 2. What's left is this 7 and this 3. We can't match them up, so we're going to go ahead and put those back inside the radical. 7 times 3 is 21. 2 times 2 is 4. And that will be our answer for what our missing leg was. And our last problem for this page is a real world connection type problem. The Parks Department rents paddle boats at docks near each entrance to the park. To the nearest meter, how far is it to paddle from one dock to the other? So this is as the bird flies, essentially. We're going from one end of the pond to the other. So we've got 350 meters and we've got 250 meters. So we're going to go ahead and say that that's a leg, that this is a leg, and this is the hypotenuse, and this is what we're looking for. We can call it C, we can call it X, we can call it Y, we can call it whatever we want. So let's go ahead and do this. We've got 250 squared plus 350 squared equals x squared. Now, right off the top of the bat, we don't really know what 250 squared is, so let's go ahead and pull out our calculators. 250 times 250 equals 62,500. And 350 times 350 is 122,500 equals x squared. 122,500 plus 62,500 equals 185,000 even, and that's going to equal x squared. Now, since it said to the nearest meter, we can just go ahead and take the square root of both sides. And for this one, let's just go ahead and give a non-radical answer just for right now. And we've got, let's go ahead and clear that off. We're going to take the square root of that to the nearest meter. We're going to round that to the nearest meter, so that's going to be x equals about 430 meters. And that is what the distance across the lake would be, roughly. If you have any questions on that, we can take them on Monday. Not a big deal if you have questions. We'll cover this to start the class. It's a bell work type of thing. Now, if we go ahead and look at the next page, we've got things talking about Pythagorean triples. So Pythagorean triple is a set of 3 integers, a, b, and c, that form a right triangle. Pythagorean triples only work in right triangles, and we're going to learn specifically about a couple, but the one we're going to learn most about is the 3, 4, 5 Pythagorean triple. The way this works is if you take 3 squared, 4 squared, and 5 squared, add a and b, remember short side, medium side, long side, a squared plus b squared equals c squared, we're going to go ahead and get, like we did on that last page, 9 plus 16 equals 25, and 25 equals 25. When you get that 25 equals 25, we're going to go ahead and know that that's going to be a right triangle for us. If we were asked to generate more sets of triples in the 3, 4, 5 family, all we really need to do is create a multiple. So essentially this one is taking the original 3, 4, 5 and multiplying it by 2. And this one is taking the original 3, 4, 5 and multiplying it by 3. So 8, 10, 12, or 6, 8, 10, and 9, 12, 15 all fall into the family of the 3, 4, 5 right triangle, or Pythagorean triple. That is the main one that we will learn about. How do we know this? Like I said before, it's just multiples of the original. This is essentially what you would call a parent Pythagorean triple. What are some other common Pythagorean triples? You've got your 5, 12, 13. Other ones you could think about are the 7, 24, 25. I mean, there is a pretty solid amount of them if you want to go ahead and Google it. I know most of us aren't all that interested in Pythagorean triples, but these two right here are the most common ones, the 3, 4, 5, and the 5, 12, 13. You'll see this, and you'll start seeing it on some of the homeworks, and when we move towards quizzes, you might see that one as a little bit more of a tricky Pythagorean triple. But we're more focused right now, at least, on the 3, 4, 5. A primitive Pythagorean triple, as an educated guess, let's just say that it's prime number triples. So just like and then the multiple is a non-prime number triple. A primitive triple, a more educated guess would say that it's a parent function or a parent triple, and the multiple is a non-parent triple. When it asks us to find the triple with 15 as one of the numbers, we kind of already did that up here. Once again, this just falls into the parent function of our parent triple is 3, 4, 5, and there's another one. Make a Pythagorean triple not already shown. These are some of the other ones. This is 8, 15, 17. That's one of the more common ones. Once again, this is the 7, 24, 25. Or you could take the 3, 4, 5 and multiply it by 4 and make it a 12, 16, 20. Any of those and all of those are part of the parent 3, 4, 5. This one is separate, this one is separate, and this falls into the parent. Lastly, Pythagorean triangle classification. We know it's going to be a right triangle if a squared plus b squared equals c squared. That allows us to say that the triangle is going to be a right triangle. Remember, it only equals c squared if it's a right triangle. If a squared plus b squared is greater than c squared, then the triangle is going to be called an acute triangle. If a squared plus b squared is less than c squared, then the triangle is going to be called obtuse. Some examples of this is if a triangle has side lengths of 6, 11, and 14, is it going to be acute, obtuse, or right? So we're going to go ahead and set this up. We're going to go short, medium, and long, because the longest side is always the hypotenuse. And we're going to go ahead, since this is short, we can go a squared plus b squared. We don't know what it is. We're trying to figure out what it is. So it's a blank, 14 squared. 6 squared is 36, plus 11 squared, which is 121. We still don't know if it's going to be greater than, less than, or equal to 196. 36 plus 121 is 157. That is less than 196. And if we go back up here and look, the less than means obtuse. This next example is a triangle with side lengths 7, 8, and 9, acute, obtuse, or right. So once again, we set it up in the same fashion. Short, medium, long. The longest side's always potentially the hypotenuse. It's always going to be the C. Here we've got 7 squared plus 8 squared blank, 9 squared. 7 squared is 49 plus 64 is blank to 81. 49 plus 64 is 113, and it is greater than 81, which makes it an acute triangle. This is something we're going to want to remember when we look towards our quiz. Our quiz is going to be not this next Friday, because we don't have school next Friday, but the following Friday. We're going to go have a quiz over the first part of Chapter 8. Here's some more examples. Once again, it's just asking, is this a right triangle? So if we go ahead and do this, 13 squared is 169. 84 squared is? I don't know it off the top of my head, so let's go ahead and get our calculator back out. 84 times 84 is 7,056. So 169 plus 7,056. That equals 7,225. Let's go ahead and see what 85 squared is. 85 times 85 is 7,225. So if it equals, we're going to go ahead and say that it is going to be a right triangle. If it was less than, then we would go ahead and say it was obtuse. Greater than, we'd go ahead and say it's acute. But since it was equal, we're able to say that it is, yes, a right triangle. Here we've got some more examples here. 16 squared is 256 plus 48 squared. 48 squared is 2304. And we're going to try to see if that equals 50 squared. So 2304 plus 256, that equals 2560. 50 squared is 2500, and that's going to go ahead and be greater than. So it is not a right triangle. So this is going to go ahead and be a not right triangle. And lastly, for these last two examples, 7 squared plus 8 squared, so 49 plus 64. We've already seen that what that equals. That equals 113. That'll be less than 121, which is 11 squared. So if it is less than, we can refer back to our table up here. So 113 is less than 121. So if it's a less than, we're going to go ahead and say that the first triangle is obtuse. Looking at our second example, 3.1 squared. So we're going to go ahead and do 3.1 squared. 3.1 times 3.1 equals 9.61. So 9.61 plus, so we're going to go ahead and clear that, see what 5.2 squared is. 5.2 times 5.2 equals 2704. Add those together, so 2704 plus 9.61, that equals 36.65. That's going to be greater than what 6 squared is, because 6 squared is 36, and if it's greater than, once again we can refer back up here, so pretty soon we're going to memorize this. If it's greater than, it's going to be acute. Now, I know a lot of us are going to think, if it's less than, shouldn't it be acute, and greater than, should it be obtuse? No. So just try to remember that greater than is going to be acute, and less than is going to be obtuse. So once again, this last example was an acute triangle. If there are any questions, don't hesitate to come ask me during North time. Make sure you're utilizing that time. Come see me at the start of class. Once again, we'll discuss this at the start of class. I'm not going to expect you guys to get this 100% without being able to ask me any questions. Hopefully this video was informative, and I hope everybody has a great weekend. I should have those tests graded and in the grade book, hopefully by Monday or Tuesday. So hopefully you have a good weekend, and I'll see you on Monday.